Well, hello, AP Physics students. I'm excited tonight. We're going to be talking about Apollo 11 and their journey around the moon. So, this is problem 48. And even though we're only about a month into physics, we're already doing problems that involve sending astronauts to the moon. So, that's pretty cool. So, here's the problem. The problem says Apollo 11 orbited the moon at a distance of 100 kilometers from the moon's surface. Use your knowledge of physics to determine how long it took for one orbit of the moon. All right, and as we all know, time is often called the period in physics, and it's represented with a capital letter T. So, what is the period of Apollo 11 going around the moon? Let's draw a little diagram here. We have the moon, and this would be the radius of the moon. Here's my little spacecraft going around the moon, Apollo 11. Now, if you look up in the front of your textbook, it will tell you the radius and mass of the moon, okay? So if you just go to the inside cover, look at that, boom, mass of the moon, radius of the moon, all right there, okay? And of course, for the radius of the moon, I would have to add 100 kilometers here to get out to my radius that the Apollo 11 was orbiting. And of course, I would want to write that in meters. I kind of like writing everything in meters. And the mass of Apollo 11, I don't know, but the front of the book told me that the mass of the moon was 7.35 times 10 to the 22nd kilograms. And any of these numbers, you can use your book, or heck, just Google it. Or if you don't know the mass of the moon, you can just ask Siri, and Siri will tell you the mass of the moon, right? I mean, check this out, right? Hey Siri, what's the mass of the moon?
Checking my sources. The mass of the moon is about 7.35 x 10 circumflex 22 kilograms.
See, there you go. Even Siri knows the mass of the moon. So just look this stuff up anyway you can find it. All right, well, let's get down to physics. Well, here's what I know. I know that when you go around the moon, you're moving in a circular motion. And when you move in a circular motion, you must have some type of centripetal force working on you, or radial force, as the book likes to call it. Well, what's providing the inward force that makes you go in a circle around the moon? Well, gravity is providing that force. All right, and that's the only force acting on Apollo 11. So I got this nice little equation here. All right, so if this is Apollo 11, the mass of Apollo 11 times its speed square divided by its radius, right? Formula for centripetal acceleration would have to be equal to the force of gravity. And by Newton's universal law of gravitation, the force of gravity between the moon and Apollo 11 would look like this. And believe it or not, I think this is the equation we can use to solve for what we're missing here. And of course, the mass of Apollo 11 is going to cancel out, and one of these r's is going to cancel out. So I can at least figure out the speed at which Apollo 11 is orbiting the moon, okay? So the speed at which they're orbiting is equal to big G, the universal constant, times the mass of the moon, times the radius of the orbit as measured from the center of mass of the moon. Well, we don't want to know the speed with which it's going around the moon. We want to know the period, or the time it takes for one complete lap around the moon. Well, I can figure that out from the speed. Let's figure out the speed. Speed is distance over time, right? So let's say for one orbit, the distance I would travel would be the circumference of the orbit and the time would be the period, right? So if this is the circumference, right, if I took that distance divided by the time for one lap, that would be the speed v. Well, I can simply, and this would be equal to 2 pi r, right? Because that's an expression for the circumference divided by t, the period, all right? Okay, so let's go over here then and do a little algebra. I'm going to take this guy then and set it equal to this guy here, okay? And I don't like this square root here, so I am going to square both sides. So I have 2 pi r divided by t equals square root big G mass of the moon divided by r. Why don't we square both sides? Because what I want to do is I want to solve this expression for big T there, right? So I get 4 pi squared r squared divided by t squared is equal to big G times mass of the moon divided by r, right? And no squareds there because by squaring I just got rid of the square root. And then if I cross multiply here, I get t squared times big G mass of the moon is equal to 4 pi squared times r cubed, right? R squared times r would be r cubed. And of course, if I do a little more algebra here, I get that big T is equal to the square root, holy cow, this is a big expression, of 4 pi squared r cubed divided by big G times the mass of the moon, okay? And if I plug all of those numbers in, I will get an answer for that. And believe it or not, if you plug all of those numbers in, you get 7,083 seconds, which is about 118 minutes, okay? So just under 2 hours is the time that it would take for you to go, for Apollo 11 to take one lap around the moon. Now, Mr. Kirsten, can I see all those numbers plugged into a calculator? Why, yes you can. Let me grab it. And here's all those numbers plugged into a calculator. I'm not sure if you can see this or make this out here. Let's get a little more contrast here. And believe it or not, if you plug that in, you get 5,000, but that is the number squared. So if I take the square root of that answer, I get 7,083 seconds. Hey, Mr. Kirsten, that's a great calculator you got there. Why, thanks. This is my TI-81 that I had while I was in Jefferson, and it still works. How about that? All right, so there we go, physicists. Nice work. For your joke today, you don't get a joke, you get a puzzle, all right? So you guys will be watching this on Wednesday night, doing your homework, I know. Well, on Thursday, the dress-up day is Superhero Day. And I'm going to give you a hint here as to the superhero Mr. Kirsten is going to dress up as. I'm going to be using this for my superhero sword. So there you go. Who is Mr. Kirsten going to dress up as? First person who gets it right might get one of these. All right? So nice work, physicists. We'll see you in class dressed up as a superhero on Thursday.